This happens to be one I call dinner, and it's basically a chicken trying to pick up a worm, and the worm keeps moving. And we have a couple of chicks that are just picking up stuff off the ground there. So, and you can see this thing runs very smooth. It's really free, and it's not. I mean, I'm just turning the nut here with my finger and thumb, and you can see it doesn't come to an abrupt stop. I'll just let it come to a stop, and we'll see. You can see it kind of slows down, and I'll do that again, and you can see that it's going to just slow down. So there's not a lot of drag. And notice also when it stops, right now the chicken is going up. But let's do it again. And now the chicken is down. He didn't even start going up. So now let's see. Oh, the chicken started going up. So there the chicken's up, there the chicken's down, and he didn't start going up. So my point is there's not a lot of drag in this system. So it really works well in the light winds. Now, it does take a little bit of wind to get it going, but it's not, doesn't take a lot. And I'm also going to work on a braking system that's going to limit how fast the shaft turns. I've got some ideas on that, and I'll share those once I put it into action and get it working properly. But much like you see here, this thing runs really smooth, and that's what I'm looking for, and I'm not going to stop until I figure it out. So I'm going to share with you now how my cam system works and how this was actually put together. So we're going to start with the chicken. He's a big chicken. He's kind of heavy because he's about 1/8 of an inch thick, and you need him to be thick so that he can stand the temperatures outside here in Florida. So I'm going to show you the cam setup now. So this is the cam, and this is a cam that's the mock-up for this design Whirligig. And I take a piece of threaded rod, and I have 3 lobes on the cam. And this is actually what's doing the work of moving the animation there. And the way this works is I have a cam lobe here, and I have a rod that's actually riding on it. Now I'm trying to do this with one hand, so bear with me. And so if we look here, and actually I'm just going to slide this on, and if I turn this, you can see that I have just a little bit of play here. Whenever the cam moves back and forth, but if I turn it this way, you can see I have a lot of play. And that's moving the cam whenever it's to the side. And this is where the rod, we're going to call this wire piece the rod, that's where it's riding on it. And if I put walls on here, then anytime the wire touches the wall, well, that's more friction. And the idea with this design is to stay away from friction. So just like if I take this rod and I hold it at the top, well, now even though the top is stationary, the bottom can still wiggle. It can go left and right. And if I anchor it midway down and at the top, now my rod really can't move anywhere as long as my anchor points don't move. And the anchor points can be simple things like holes in something where the rod can move, but it can't move very far. And because I have 2 points that are anchored, one being where it's attached to, in this case, the chicken, the other where it goes through the top of my base here, which I'll get into my base also. Because I have those 2 anchor points, this rod cannot go anywhere. The only thing it can do is move up and down. And that's what the cam does. The cam rotates and moves the wire up and down. And because my rod is wider than it is high, then the cam only affects it going up and down. So therefore, the only time I get friction is whenever I'm pushing it up or pushing it down. I don't want any side to side movement of my rod, so therefore my lobe is big enough that the cam can turn inside of it and not put any load on it. So therefore I have no friction on the side. That's where if my cam was set up with a rod that was round and the round rod traveled around the crankshaft, or in this case the camshaft, then I've constantly got load all the way around. But in this case, I'm only putting load at the bottom and at the top. So that's how I eliminate probably 90% of the load, because my contact points are really small at the bottom of the rod and at the top of the rod. And also my rod is nothing more than a bent piece of wire. And I made this fixture, that's what this is. This is a fixture that allows me to make my rods, and my rods they come out perfect every time. So here you can see my wire that gets bent around my fixture, and it's fairly tight. And at the top, I have on the 90-degree bend, I have it bent out slightly to create a little bit of a grab onto the brass tubing that I put over the two pieces of wire, and I mash it down so that that's going to secure these two pieces of wire together. And of course it's wrapped around this fixture, which has been ground and sized so that I get the proper shape in my rod that I'm creating. Now you can also tell here there is a bit of an offset. In other words, that wire is not in the exact center, and that's by design. I do not want that wire, this one, in the exact center, because my chicken is actually taking up part of the center. So you can see he's off center a little bit. So therefore my rod needs to be off center. So that's why I have him off centered. Now you can do another rod, and you simply put the first bend in it and then shift it over to wherever you need your offset. And if you don't need an offset, well then don't have one. But in my case, I've designed this so that the two areas that use this rod, which is the chicken and the little chicks up front, notice that that wire is just off center slightly. And of course that means that I can have one rod that'll work in two places. So that's how my rods are made, and like I say, they come out perfect every time. This is how my cam works now. I use a threaded rod, but I also, in my cam lobe design, I've created a nut pattern. So what I can do is take and slide my cam where I want it, and then slide it over that nut. Now this cam is locked to the rod as long as these nuts are jammed together. And then once I get it where I want it, well then I can run another nut up on the other side. And you're probably thinking, well, why don't you just use a lock nut? Well, the problem is whenever you use lock nuts, if you run them any distance on whatever it is you're putting them on, by the time you get the nut where you want it, the nylon has gotten hot enough that it's no longer really a lock nut. Yeah, it's got some friction on it, but it will back off. So I simply just use two nuts and jam them together. And of course it doesn't have to be jam up tight, but you want the nuts to be tight. You don't necessarily want to be, jammed up on the plastic here. So you don't have to crank it down whenever you go to jam it up, but you do want to make sure your jam nuts are tight, because you don't want the nuts coming undone. But this here can actually float or wiggle slightly on the shaft. And so this is my master. This is the mock-up. So this rod is exactly what is inside of this particular model here. And you can see that goes to the end there. Here's where the first lobe is for this action. Here's the second lobe for the worm action, and here is the third lobe for the chick action, and of course the prop mounts to it, and so on. So that is my cam setup. These are 3D printed lobes, and this, I just printed this one out of yellow because that happened to be what was in the spool whenever, or what was in the printer whenever I decided I would print some of these to make this video with a little different contrast. So it worked out really well. So that's on the cams. I also designed a spinner. Well, you can see that it's just 3D printed, but on the inside I have a magnet, and I also have a nut pattern in there that's 7/16 so that it will slip over the 7/16 lock nut and fit onto the nose and create a nose cone design. Now the other thing is, the only thing that I'm lacking here that I will be doing is I need to drill 2 holes. I'm going to put a hole back here, and I'm going to put a hole up front here. And the reason for those holes is because I have openings in the front or on the top, and I'm going to get water in there when it rains because these are going to be left out all the time. So I need a way for the water to get out. And as long as the water can get out, well then it won't build up and wind up in the bearings. And that is these end caps here. You can see in this end cap that I have a bit of a slot right there. And of course I have a couple here that I've already printed because I'm getting ready to make another one. So you can see the slot. And of course this end cap goes on like that. And of course the bearing goes on the inside there. It's a flange bearing, and but what's unique about my end caps is I have this little slot here. And this slot is so that whenever it rains, and these are going to get water on them, but this is going to be unique in that the water is going to run down and wind up into that bottom hole because of gravity. And of course it will run out rather than build up. So I designed these to help protect the bearings that are in the Whirligig. Also the main shaft, these are not anchored to my tube that I created. And it is a piece of 2-inch, and you can see here it's 2-inch. It is a piece of 2-inch thin wall PVC that I've reshaped. And I go about reshaping it with a fixture. So what I do is I heat this up, and once I've gotten it pliable, in other words you can squeeze it and it's really flexible, I heat it at 350 degrees for about 4.5 minutes. And at 4.5 minutes I take it out of my heat source, and I slide these 2 pieces of wood, which if you look close you'll see that they're wedge shaped. I slide these 2 pieces of wood into it, and then I simply push them together. Now if I get it in there and it stops or it binds up, well then I take the whole thing and put it back in my heat source. And I have a vacuum form machine that I use for the heat source. So I basically heat the PVC pipe up 350 degrees for about 4.5 minutes, pull it out, put the wood in there, slide the wood together. The idea is whenever the wood is together on the end and it's sticking over about 1/8 of an inch, then that's where I stop. And then I let this cool, but first I make sure I lay it on its side and I press it down so that it's flat. And once I get it where I want it and it cools, then I simply tap on the end of this. And of course the more I tap this in, the closer these come together. And of course it doesn't take much, only a few taps, and my wood falls out and I'm left with the exact shape that I want, only because I set up and cut these wedges on my CNC machine so that they are the perfect size for my project. Here's a look at the chicken as it's being printed on the 3D printer, and you can notice the head, the location for the beak, as well as the comb. I've designed that so that they fit into slots. It's more of a tongue and groove type of thing. And then also there on the back there, you see that is the part of the head that is going to cover this area here. And whenever they're all put together, this is what they look like. Also, I have wing detail that gets glued on, and the head gets glued on. But those notches you've seen, I have the comb that fits in, as well as the beak that fits in to those slots. And that's what makes up my chicken. And then the feet, I also print up some feet. So there's the feet, the beak, the comb, and you see the head and the body being printed on the 3D printer now. If you have any questions, you can leave a comment or send me an email, and I'll be glad to answer them if I can.